Hi, this is Mrs. Murdock, and I am reviewing monomers and polymers today. So first of all, let's make sure we understand what the difference between those two terms really means. A monomer is a generic term. Okay, it's a way to classify lots of different molecules, and all you have to do to be a monomer is to be a small molecule that can be repeated and bound to become a large molecule. In simplest terms, that's what we're talking about, right? It's like a monomer. I think Mr. Bouchard was talking about Legos, right? That you can take one little Lego piece and bind it to lots of other Lego pieces. The single Lego piece is the monomer. The lots of Legos is the polymer. So if I go on to define polymer here, that's exactly what I'm going to say. I'm going to say a polymer is a large molecule made of many monomers, so that you have a long chain of them. That's it. Okay. So now let's go a bit into examples, because some students get confused about exactly how you use these words and what they have to do with what you've already learned, for example, about carbohydrates. So let's apply it to carbohydrates. So if I go down here and I kind of make a little sort of a table, and I say, okay, I'm going to put examples of monomers under here. And then I'm going to put examples of polymers over here. I'm going to leave a little space between, because sometimes there's sort of in-between molecules that aren't monomers but aren't big enough to be polymers, and we'll talk about those, right? So we've got monomers and polymers, and then we're going to talk about carbohydrates, because that's the first one we've already talked about, and you might recognize those the best. So carbohydrates, the name of all the monomers in the carbohydrate group, they're called monosaccharides. Monosaccharides. And the names of the polymers in the carbohydrate group are called polysaccharides. And then you can talk about the examples of each. So examples of monosaccharides, the most famous one we've talked about is glucose. Glucose, which has 6 carbons and 12 hydrogens and 6 oxygens. That's one example of a monosaccharide. There are others. Fructose is also a small carbohydrate. And so is galactose. That's another one. These are all actually very small, very similar in size and shape to glucose, but slightly different tasting if you put them on your tongue. Fructose is actually said to be a little sweeter than glucose. And then if you go over here, pull my thing down a little bit more. There we go. Okay, so if I have a whole chain of glucoses, I can get things like starch, which is an example of a polymer of glucoses. So is glycogen. Glycogen is a polymer of monosaccharide molecules. These guys put into long chains make starch and glycogen. Okay. Now there's actually an in-between with the carbohydrates called disaccharides. Disaccharides. I always have trouble spelling these. There we go. Okay. So disaccharides are when you put only 2 monosaccharides together. So it's not small enough to be a monosaccharide, but it's not big enough to be a polysaccharide. So the most famous example is that one that I put on your bonus sheet, sucrose, right? So sucrose is actually a disaccharide made of a glucose bound to a fructose. So those 2 monosaccharides make a sucrose molecule. And that's the most famous one of all. That's the one you know. That's the one in your sugar bowl at home on your mother's table, right? That's the big bag of sugar your mom uses to make cookies and cake. That's sucrose. And the other one that I will go over because we'll see it in the pear deck is called maltose. You guys like malts? Do they even make malts at the soda shops anymore? And maltose is the type of sugar they use to put in a malt. Okay, so it's also sweet. And a maltose is made of a glucose bound to a glucose. So it's also a disaccharide. So starting to help a little bit? Okay. So if I went over, I could also go over the other molecules over here, the other types of organic molecules. I could go over proteins. And I could go over nucleic acids. I don't want to touch on those too much right now, though, because we haven't learned them yet. But the point is that all of these different types of big organic molecules have their own type of monomer in them. Okay, so all proteins, the monomers of all proteins are called amino acids. Amino acids. And there's 21 different examples of those, and I won't go over them, all of them, but like alanine is one, and we'll learn that later, and there's lots of them. And then if you put a bunch of proteins together, you get something called a polypeptide. Is what you call lots of amino acids strung into a chain. And an example of that, well, there's lots of different proteins, such as hemoglobin is a really famous protein that we'll talk about this year, which is a long chain of these amino acid monomers over here, right? Okay, we'll go too much further into that. Nucleic acids, the monomer of all nucleic acids is called a nucleotide. A nucleotide. And if you put a bunch of nucleotides together, the polymer that you get is one of the most famous ones is DNA. Oops, moving my screen here. DNA is a really famous polymer with lots of nucleotides in it, and the other one is RNA. Okay. All right. So that was what I wanted to explain about that. Now the one last thing I'm going to talk about is a chemical reaction that can put these two monomers together that we're going to learn about today is a little bit difficult to visualize. You're going to see it in the ed puzzle that you do before we come to class next, and you'll see it sort of on the pear deck too. But I wanted to draw it for you to give you a first idea. So how do you link two monosaccharides together? And in fact, the way to link any monomers together, it's the same reaction. It's called dehydration synthesis. Dehydration synthesis. And you may have remembered this from your life science in the 7th grade and maybe not. But what it is, it's a chemical reaction where you take a glucose molecule, and glucose molecules look a lot like this, and it has a hydrogen sticking up here and an oxygen and hydrogen sticking up there. And you put it in close contact with another glucose molecule, drawn exactly the same way, that also has a hydrogen here and an oxygen hydrogen there. And it goes through a chemical reaction where the OH from this molecule is combined with the hydrogen from this molecule. And if you put two hydrogens and oxygens together, what do you get? You get water. That's it. So off comes the water. Dehydration, right? Dehydration means water is lost. And what's left is this oxygen is still here, and it's going to kind of reach over and shake hands with the glucose. So you wind up with two glucose molecules that are now stuck together, sort of shaking hands with that oxygen. Now that those two hydrogens and oxygens are out of the way, you now have a disaccharide, right? You had a monosaccharide glucose here, another monosaccharide glucose here. You took water away and caused them to bind together here. And now you have a disaccharide called maltose. And that doesn't have to stop. you can keep adding glucoses, more and more and more glucoses on this end until you don't just have a disaccharide, you have a polysaccharide that's nice and long. And that's exactly what some of your cells, especially in your liver, will do. Because they'll take glucose, if there's any excess glucose around, they'll take it and hook it up into long polymers of glucose to store that energy to keep it for when you're in trouble, right? Or when you're hungry and you need to re-release it and put it back in your bloodstream. All right, so that is all I wanted to talk about today, just the review of what monomers and polymers are and how you use those words with carbohydrates, and the dehydration synthesis reaction, which can take two monomers and put them together until you have a polymer. And thank you, and I hope that was helpful.